Alrighty, I'm going to finish where I left off because I didn't get to finish. So I put in my previous answers exactly how I did it earlier, and now I am going to finish from there. So I left off on question number, let's see. I left off on question number Where did it go? Oh, I left off on question number 19. So again, I am starting where I left off to save time. I didn't want to read through every question and do that again because I have 30 minutes to finish this. Okay. Job satisfaction surveys have shown that a person's job satisfaction is often related to their academic major. The two-way table below summarizes the results of a job satisfaction survey of 325 college graduates who are currently working in a full-time job. Okay, so accounting has 90 satisfied, 35 unsatisfied, total 125. Linguistics has 24 satisfied, 36 unsatisfied, 60 total. Engineering has 95 satisfied, 45 unsatisfied, 140 total. And total satisfied is 209, total unsatisfied is 116, total, and the total is 325. So, which statement below accurately describes a relationship between job satisfaction and college major for people in the two-way table above? Let's see. Oh, let's see. Accounting majors are more likely to be unsatisfied with their job than engineering majors, or linguistic majors are more likely to be satisfied with their job than accounting majors, or engineering majors are more likely to be satisfied with their job than linguistic majors, or each college major has the same percentage of satisfied students. Um, So we're trying to determine the relationship between the job satisfaction and the college major. Um, so let's see here. We actually need to calculate the percentage of satisfied accounting graduates. Well, all of them, the linguistic, the engineering, and that's by putting the satisfied number over the total number for each one. And then those percentages are going to be 72, 67.86, and 40. So the engineering and accounting majors are more likely to be satisfied with their jobs. Um, so linguistic majors. So which statement below accurately describes a relationship between accounting, linguistic majors are more likely to be satisfied. Uh, Engineering majors are more likely to be satisfied. engineering and accounting are more likely to be satisfied than linguistics because they have a higher percentage. So, but there's only engineering majors. Okay, I will choose that one. Let's see. Um, so using the two-way table, if a person from that sample is randomly selected, what is the probability that the person is both an accounting major and satisfied with their job? 0.28, 0.43, 0.72, 0.90. Let's see. Well, you have to, the probability is the number of the satisfied accounting majors divided by the total number of the graduates. So it's going to be 90 over 325, which is going to equal out to 0.28. All right. Suppose you plan to roll a six-sided die 2 times. What is the probability of rolling a six both times? I think that's going to be, well, the probability of rolling a six twice is going to be 1 over 6 times 1 over 6, and then that's going to equal 1 over 36. A student decides to do 6 independent flips of a coin that has one side heads and the other side tails. On the first 5 flips, the coin lands on heads. What is the probability of the coin landing on heads on the student's sixth flip? Oh. I think, let's see. Well, the probability of the coin landing on heads on a sixth flip is still going to be 1/2 because there's only 2 sides to a coin. So that's easy. Samantha took an exam in her statistics class and received 90 out of 100. Samantha thought that was a good score, but she wanted to know how high her score was in relation to the rest of the class. Her professor said her Z-score was 1.29. How should Samantha interpret her Z-score? Okay. Samantha's score is 1.29 above the class mean, or Samantha's score is 1.29 times above the class mean, or Samantha's score is 1.29 standard deviations above the class mean, or Samantha's score is 1.29 standard deviations below the class mean. I think for this one, um, shoot. I think that this means All right. I think it means her professor said her Z-score was 1.29. How should Samantha interpret it? I think it's 1.29 standard deviations above. I think above the class mean because 90 is a pretty good score. And I know it's standard deviation. The owner of a senior living facility is trying to understand data about the age of its residents. She finds that ages are normally distributed with a mean of 69.5 and a standard deviation of 11.5 years. What is the Z-score for a person who is 90 years old? Is it 1.15 or 1.78 or 6.04 or 21.5? Oh, let's see. I think to solve this, you have to do the mean is 69.5. Standard deviation is 11.5. The age of the resident is, let's see, score. So it's going to be 9 minus 69.5 over 11.5, which will equal negative 60.5 over 11.5, which equals negative, oh no, I'm not getting this. I think that it is, I'm not sure. I'm getting like a 5 point something number. So the closest to that is 6.04. Okay. For normally distributed data, what is the probability that a data point will fall within one standard deviation of the mean? I have this in my notes. I have this in my notes. Um, so let's see. Fall within one standard deviation of the mean. So one standard is 99. For normally distributed data, it's 68%, according to my notes. Okay. For the following study, indicate whether it is an observational study or an experiment. Explain your reasoning. If it is an observational study, give the population and the sample. If it is an experiment, give the explanatory variable and the response variable. Okay. Just prior to the first episode of Game of Thrones season 5, a polling company surveyed 1,000 of HBO's subscribers to see how many planned to watch. After the poll, the company predicted that 35% of HBO's subscribers would watch the first episode. Okay, so let's see. I believe that this is I think it's observational. Oops, sorry, I keep trying to get comfortable. I believe it's observational because, oops, um, the researchers are observing and recording data, which is the survey responses, and recording data, which is the survey responses. Oh my gosh, I can't type. Which is the survey responses without, whoops, oh my gosh, manipulating any of the variables. And that's obviously what makes it observational. And let's see. So if it's observational, give the population and sample. So the population is the HBO is the HBO subscribers and oh my gosh, subscribers, and the sample is the 1,000 surveyed subscribers. Ugh, okay. All right, here goes another one. For the following study, indicate whether it is an observational study or an experiment. Explain your reasoning. If it is an observational study, give the population and the sample. If it is an experiment, give the explanatory variable and the response variable. Okay. A New York doctor wants to study the effects of exercise on the number of calories students eat at Eastern New York College. He selects 200 students and randomly divides them into two groups. He instructs one group of students to exercise for 1 hour each day and instructs the other group not to exercise. He then asks the students to report the number of calories that they eat each day for 1 week. He compares the two groups on the average number of calories eaten. Okay, so this is gonna be a um all right. I think that let's see, the doctor wants to study the effect of exercise. So this is gonna be an experiment. This is an experiment this time because there is something being manipulated. The doctor is manipulating, the doctor is manipulating the exercise condition um, by assigning groups. So it's not at random. The doctor is manipulating, or the doctor manipulates, sorry. The doctor manipulates. Okay, and then um the explanatory variable is the condition of exercise. And then the explanatory variable, and then the response variable is the number of calories. 10. Oops. Okay. A gardener wants to see if there is a difference in height for his two tallest types of flowers, sunflowers and oriental lilies. The gardener measures a sample of 10 sunflowers and 10 oriental lilies in his garden. The height of the flowers in feet is given below. So, sunflowers have 1.9, 2.7, 2.9, 2.9, 3.4, 3.4, 3.7, 4.0, 4.0, 4.4. Okay. Oriental lilies have 2.8, 2.9, 3.0, 3.4, 3.4, 3.6, 3.6, 3.6, 3.7, 4.0. Determine and enter the five-number summary for the height in feet of the flowers. Enter answers rounded to the nearest tenth. Okay. Sunflowers minimum. Um, minimum Q1, median Q3, maximum. Okay, let's see. I'm just trying to dig up my notes because I do not remember all of this. Um, okay, so the minimum is obviously going to be 1.9. And then the the maximum is going to be, I know, 4.4 for this. So then to find the median, I need to do the 3.4 plus the 3.4 over 2. 3.4, yeah, because those ones appear the most, over 2. So yeah, the median is 3.4. And then to find the Q1, you have to do the median of the lower half of the data, which is going to be the first five values. So 1.9, 2.7, 2.9, 2.9, and 3.4. So it's the middle value of the lower half. So that's going to be the third value, which is 2.9. And then the Q3 is going to be, excuse me, my nose is really running and that's gross. I'm sorry, I'm sick. The Q3 is the upper half middle, so that's going to be 4.0. And then the same thing for the lilies, oriental lilies. Um, um, so same thing again. So the minimum for the oriental lilies is 2.8, and then the maximum is 4.0. So for the median, it's going to be the 3.4 plus 3.6 divided by 2 is 7.0 divided by 2, which is going to be 3.5. And then the quarter one or Q1 is going to be the lower half median. So since there's 5 data points, then it's going to be the middle value, which is the 3.0 out of the first 1, 2, 3, 4, 5. That's the middle value. And then the Q3 is going to be the middle value between the upper half, which is going to be 3.6. Oh my gosh, 5 minutes. This is taking me forever. Okay, let's see. So, describe the similarities and differences in the height of flowers in terms of center and spread. Um, well, sunflowers and oriental lilies have similar mean heights, but the sunflowers have ultimately a greater spread in height. Ugh, my goodness. Eek. Okay, gonna try to get through this. The owner of a new social media website decided to launch a big advertising campaign in January 2014 to increase the number of active users on the website. She then tracked the number of active users each month to see if the advertising campaign worked. The data she collected is shown below. The model that fits this data is y hat equals 10,000 times 1.21 to the x power. X is the number of months since the launch of the advertising campaign in January 2014. Is the same model of exponential growth, decay, or neither? Explain your answer. Um, I think that this model shows exponential growth because the base of the exponent is 1.21 because the base of the exponent, sorry, 1.21 is greater than 1, indicating that the number of active users increases over time. Gosh. Okay. Interpret the two numbers in the model. Excuse me. Interpret the two numbers in the model 10,000 and 1.21 using the context of the study described. Um, Interpret the two numbers in the model 10,000 and 1.21. No, my notes, I don't know. Ugh. Shoot, I'm stuck on this last one. 10,000 and 1.21. Uh-oh. All right. Let me stop sharing and save this recording for part 2. It's taking me so long to finish. Sorry.